Hey everyone, this video is going to go over lesson 9.2, which is graphing logarithmic functions. So up to this point, we have talked about exponential functions, we have talked about, so what this one is going to kind of go over, it's going to kind of bring together all of those things. So because we want to start talking about graphing logs are the inverses of exponentials, okay? It's pretty simple for us to set up a table of values for an exponential. I'm actually going to just kind of review with you guys graphing this exponential. We're going to do f of x equals to the x power, which was also covered in lesson 8.2. But just so you guys see it again, I already gave you kind of the x values that we're going to plug in. Remember, they're going in to that exponent spot right there. So if you take 2 to the negative 3 power, remember negative exponents make fractions. That's going to be 1/8. 2 to the negative 2 power is 1/4. And 2 to the negative 1 power is 1/2. So there's all our fractions. 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. So that's where all of our points are coming from. Okay, so we have a decent number that we can put on our grid. Remember, the fractions are kind of difficult. Remember, they're supposed to just be between 0 and 1. So in this case, since these are all y values, keep them between the x-axis and then the very first y grid line. So if I go negative 3 1/8, left 3, and somewhere in between here, basically just right above the x-axis, we put the 1/8. For negative 2 and 1/4, negative 2 up maybe just a little bit, but barely. And the next one, negative 1 and 1/2. So negative 1/2 is a little easier to manage. It should be in the very middle of the x-axis and the 1 on the grid line. The rest of these should be pretty straightforward. 0, 1, we graph here, 1, 2, is here, 2, 4, is here, and then 3, 8. We graph this last one. And this is kind of a basic outline for our exponential function. Okay, so we connect these. Remember that the exponentials, so they always have to hover around a horizontal line. So in this case, it's the line y equals 0. It's kind of hovering right above that. It's not going to touch it. It's not going to go below that. Okay. Also, there ends up being 2 reference points. In this case, the 2 reference points, using those basic function rules, 0, 1 should be 1 reference point, and in this case, 1, 2 is going to be the second reference point. Okay, so if you just had those 2 points, you should also be able to make kind of a skeleton of this exponential function. But you could also make a table and graph a couple other points. Okay, so here's the point of doing this. Since we just learned that logs are the inverses of exponentials, now we're going to talk about graphing the log base 2 of x. Now, because we've already made this table of points, and we also discussed at the end of lesson 8.3 how to graph inverses. So the rule for graphing inverses is that you just take the x and y's, meaning the points, and you flip them around. Okay, so we are switching the x and y's of 2 to the x because that's the inverse function. So for each of these, I'm just going to take them, kind of go through my grid here and just flip them around. So 3, 8 becomes 8, 3. 2, 4 becomes 4, 2. 2, 1 would be the next point. 1, 0 would be my next point. And then I start flipping the fraction. So it's 1/2 and 1. 1/4. Oh, sorry, negative 1. 1/4 and negative 2. And then 1/8 and negative 3. Now these are going to be my points on my log function. Okay, so I go to graph these. I have 8, 3 goes here, 4, 2 goes here, 2, 1 is here, 1, 0. And now this time when it comes to the fraction, since all of these are x values, that means they have to be somewhere in between the y-axis, meaning like the 0, and the 1 on the vertical grid. So if I go 1/2 and negative 1, I need to go between 0 and 1 and down to 1. 1/4 needs to be between 0 and 1 at negative 2. And 1/8 needs to be between 0 and 1 down at negative 3. So that's kind of where those halves and fourths and eighths are kind of going. But notice the direction of this log. So I go kind of, well, I can't really even go very far left. It looks like it almost just goes straight down right here. And then it goes up and over slowly to the right. Okay. So this is a basic log function. And that's kind of the general shape of our logs. All right, so a couple things to kind of notice. Those reference points. Okay, so they change a little bit here because they were changed from our exponential function. They're still kind of the same too. They're just in a different order. So our first reference point is 1, 0 instead of 0, 1. And our second reference point is 2, 1 instead of 1, 2. Okay. The asymptote this time, if you notice, with those fractions, so if you kind of follow the fractions a little bit, you're getting really close to the y-axis, and of course, I mean, my pen looks like I touch it because I can't zoom in enough to not touch it. But ideally, like if we were graphing this with technology, we wouldn't actually be touching the y-axis. We would get really, really close. We're not going to cross it. And the reason being is because as far as inputs, if x is the input here for our log, you cannot input negatives into logs. I don't think that's something we really talked about in the last lesson, but it is something to take note of here because then that should make sense. I can't have any negative x's if I can't put any negative numbers inside this. So our asymptote this time, instead of y equals 0, we need it to represent the y-axis, so it's the line x equals 0. Okay, horizontal lines always start with an x. So maybe if you want to make a note of that, like x means the horizontal line. Okay, so that's just to kind of give you an idea of how you can graph a log function, or at least kind of come up with the shape. General shape, or this is the general direction that they will go. They will always have a vertical asymptote. Oh, wait, vertical. Wow. I bet I just said the word horizontal like 5 million times, didn't I? Wow, this really is like class. I can still make mistakes. Okay, moving on. Okay, so we're going to have some rules as far as our finding our reference points for logs, okay? Just like we had rules to find reference points for exponentials, same thing applies when we have logs. So if we take a look at the basic functions, so remember we have basic functions and we have extra functions. Let's say that this first one is basic because it's just a log base b of x, okay? So pretty similarly to the exponential, the very first reference point, instead of 0, 1, it's just 1, 0, okay? Any basic one has that first reference point. Second reference point is going to be b1, so whatever the base number is, and then a 1 is going to be our reference point. And then this time, like I said, instead of y equals 0, our asymptote is x equals, and then 0 for the basic function. Okay. Now, if you look at this next one, lots of extra things happening here, right? There's an a in front of the log. There's x minus h inside the log. And then after the log, it's a plus k. So this is our extra function. Okay, remember, basic is just log base b of x. Extra has, other things in it. So here's our rules to finding these reference points. First reference point, it's supposed to be 1 plus h, and then the k value. So very similarly to our exponential rule. The second reference point is where it's going to be a little bit different. The second reference point is b plus h, and then a plus k. And our asymptote. So since we're trying to find a vertical boundary this time, meaning like you can't go, any farther left or any farther right, the point or the part of the formula here that kind of restricts vertical movement is the h value. So x equals h is going to be our asymptote this time. Okay, so remember, like with our exponentials, it was always y equals k, because k determines how far up or down you can go. Well, h determines how far left and how far right you can go. All right, and since we didn't do this last time when we talked about transformations and exponentials, I want to just kind of write down some basic transformation rules again, so you guys, just kind of get in the habit of recognizing, like, if there are certain numbers in certain spots in your equation, like this is how they're going to move your graph around. Okay, so for A, remember that A changes the graph, like meaning this number in the front. It's changing it by a vertical stretch or compression. Okay, so remember vertical stretch, it's getting taller. Vertical compression means it's getting shorter, and the points would be moving closer together. In order to do a vertical stretch or compression, like basically you're just taking that A and you're multiplying it to the y value. Like whatever your y is in your point, or the point that you're trying to change, you'd be taking a times y to do the vertical compression. Okay, or vertical stretch. There we go. All right, so second thing, h. Okay, so anytime you have an h, usually it should be, being added or subtracted to the x value. So it should be kind of included with x somewhere. First and foremost, this is like just a special note to make. Remember that you always have to change the sign for h. Remember, in the formula, it says subtraction, but that means you need its opposite sign. So always change the sign. Right. And the type of movement, remember that if you're adding or subtracting a number to x, that's a left or a right movement. Okay, or a shift. We call those shifts. Is the opposite of what you would think. And basically, like in order to determine like how this is going to move your point, you would have to take x, whatever your x value is, and actually add or subtract whichever one you're, whatever sign that h has, and you'd be adding or subtracting h. Okay, that's how you're going to move left or right. Okay, so the last type of change you can have is for k. Now k you keep the sign for, you're not going to change anything there, but it is also a shift. Well, probably shouldn't put those two together. Okay, so you are shifting up and down. When you have a k, if k is positive, that means it's shifting up. When k is negative, you're shifting down. So in order to do a vertical shift, you would have to take your y value and you would have to add or subtract k, whatever it is that the sign is for k, in order to complete that shift. Okay, so like I said, these should have been covered last semester when you talked about transformations, but I just want you guys to remember, like, they can still be applied to other types of functions. So since we're learning some new functions, like some exponentials and logs, I just wanted to kind of, rehash these things and make sure you guys understand like they still work the same way. All right. So here's what we're going to do. So very first example of graphing a transformation in a log. Basically, we have this function here, f of x equals 3 times the log base 4 of x minus 2 plus 8. And we kind of need to pick out some information. So basic function, let's start there. So if you look at this thing, like it's very extra, right? You just want the basic parts. Well, the basic parts are the log, the base number, and the x. Okay, so this parent function is just log base 4 of x. And since we've already talked about the base is 4. And it shouldn't take us too long to do this. Let's talk about if we had the basic function, like what would its reference points be? So the reference points here, we will always have 1, 0, right? Like that is always a reference point for a basic function. And the second reference point would be b1. And in this case, since the base is 4, it would be 4, 1. That asymptote would be x equals 0. That would be something to kind of also notice. Okay. So we're going to talk about those here in a second. Let's now go through and write down all our parameters. So remember, the parameters are the extra pieces of our function. So our a value, a should always be in the front. That is the 3 in this case. H is always on the inside. Since this says minus 2, change that sign. It's going to become positive 2. And then our k is at the end. It is positive 8, so we'll just keep it positive 8. There's our parameters. And that's the information that we need to use whenever we write down our rules for our reference point. So first reference point, the rule says we want to take 1 plus h and then put in the k. So in this case, if I fill things in, 1 plus 2, and then k is 8. So I'll fill that in there. Our first reference point, when we simplify that, is 3, 8. Okay. Second reference point. So we're using the rule from before. It is b plus h, and then a plus k. Okay, so if I plug in the numbers from my problem, like all these parameter, we have b and h, which is 4 plus 2. And then a plus k is 3 plus 8. Okay, so that gives me the point. 4 and 2 is 6. 3 and 8 is 11. Okay, so there's a second reference point. Notice that 11 might not go on my 10 by 10 grid, but that's okay. We'll kind of just estimate where it is so you kind of see where the shape would happen. And then lastly, our asymptote, it's supposed to be the value of x equals h. So we need to put the x equals. Remember, that's what makes it an equation. And then our h is 2, so we'll put a 2 there. Okay. So here's what I'm going to do. I'm actually going to draw in our basic parent function first, just to give you an idea that we are doing the right transformations, like things are moving in the right ways. Like I just kind of want to tie this back to old stuff. So not saying you really will have to do this in future problems. It's just something to kind of notice here. So for our basic function, log base 4 of x, we have 1, 0. And we have 4, 1 as our points. Since our asymptote is at x equals 0, that is the y-axis. So I'm going to keep it close to the y-axis, but I don't want to cross it. And then I want to go over. It's growing a little bit more slowly on this one, or it's a little more, I don't know, a little more pointed, it seems like. Okay, that's kind of like where our basic function is. Let's take a look at where our new function, our extra function is. So we have the 0.38. So I'm going to graph that. 3, 8 goes here. And I have the 0.611. Remember, 611 goes a little bit off my grid, but just to kind of keep in mind, it would be just right above. That's where our second point is. And the asymptote line of x equals 2. I'm actually going to do this in a different color. let's see here. Let's do this. Just so we know, like this is a line. It's not necessarily part of our function. It's just a line. It's like a reference line. Like you're not really supposed to go past it, right? Like it's a boundary. Anyways, x equals 2. So you find where x equals 2, which is right here, and then you draw a vertical dashed line. Like that's how our asymptotes should look. And then now I want to connect these 2 points so that they kind of form the same type of shape as my parent function. So I'm going to, well, it looks like I kind of need to almost just go straight down on this left-hand side, but then I connect them up and over, and I'll kind of curve over there. So it's a little bit different. But here's the things to notice, right? So all of these shifts that were happening, or all these things that were happening. So when A is 3, that means it was a stretch of 3, like a vertical stretch. With H being 2, that means it should have shifted right 2. And with K being 8, it should have shifted up 8. Like that's what each of those numbers technically mean. So kind of think about the points from our parent function versus the points that are, on our function now. So if I were to go from 1, 0, and I go right 2, and then I go up 8, so right 2, and then up to 8, well, there's that new point, right? Like that's exactly where it ends up. Kind of similar here with the second point. If I go right 2, now I will say I'm not necessarily going a little bit more. So if you think about it, you're actually going up 10, but the reason is because these 2 points right here, they're supposed to be stretched farther apart. Because we have a vertical stretch of 3, they did stretch further apart, whereas like our first 2 were just kind of like, they had a vertical difference of 1. Well, now these should have a vertical difference of 3. Like if you look right here, that would be our vertical difference. So that's kind of why these are a little further off. But that's how the transformation should work, right? Like we do move right 2, and we do move up 8, and we did stretch our points out some. Okay, so just to give you an idea, again, trying to make connections to old things, bring them back into our newer stuff, because there are things to keep in mind. But I do want to wrap this up. Sorry that this is going a little long. Let's just take a look at number 4 real quick. I just want to see, can you tell me the transformations that are going on here? So more or less, you're supposed to pick out the parameters and basically say what each of those parameters do, right? So if you look, is there an A? Yeah, there is an A. Since A is -2, that means that there is a vertical stretch of 2, and technically because it's negative, if you remember what negatives do, I think a lot of people suggested this whenever they saw A, when we discussed transformations the first time. Negatives flip your function. Okay, so this would actually turn your log function upside down. Okay, that's what the negative part does. Next up, look to see if there's an H. In this case, yes, there is. H happens to be 4. Since you are changing the sign, like if you see a minus in the problem, that means it's really going to the positive direction. It's moving right 4, or it's shifting right 4. Maybe I should write that instead. And then lastly, you look to see if there's a K, and yes, there does happen to be a K here at the end. K is 3, and since 3 is positive, it is shifting up. Okay, so again, just to keep these in mind, I want to make sure that you guys are remembering these things. We are actually going to practice this on Tuesday when we get back. So hopefully you watch this video and you have somewhat of a clue as to what's going on. If not, Tuesday's going to be kind of rough. So anyways, if you have any questions, just let me know.